You are surrounded right now by things that are paying attention to you, and none of them has a brain, not in a creepy way. Step into a garden, a park, a patch of weeds by the road, it looks like the most settled, sleepy scene on Earth. Nothing moving except a little wind. And almost everything you just decided was doing nothing is, at this exact second, sensing, measuring, and reacting, with no nerves, no eyes, and no single place inside it where any of that could be happening. We tend to file plants somewhere between furniture and scenery. That filing is the mistake. Pull on it and the whole idea of what a mind is starts to come loose. Start with the one that's easiest to catch in the act, the Venus flytrap. Everyone knows the trick. The bug lands, the trap slams. What almost nobody knows is that the plant won't close on the first touch. It waits for the second. Inside the trap are tiny trigger hairs, and brush one just once and nothing happens. Brush a second one, or the same one again, within about 20 seconds, and the trap snaps shut in a tenth of a second. Wait too long, and it's as if the first touch never happened. It resets. In 2016, a team led by Rainer Hedrich at the University of Würzburg worked out what's going on, and it's better than the magic version. Each touch fires off a tiny electrical pulse, an honest-to-goodness action potential, the same basic event that runs along the nerves in your own arm. That pulse raises the calcium level inside the trap's cells a notch. One notch isn't enough. A second pulse arriving in time stacks on top of the first, the calcium crosses a threshold, and the trap fires. They called it a calcium clock. And here's the part worth sitting with. The plant is, in a real and measurable sense, counting. It counts to 2 before it bothers to move, and it'll keep counting, up to about 5, to decide how hard to start digesting. Now, why would a vegetable bother to count? Because slamming shut is expensive, and the world is full of false alarms. A raindrop, a bit of wind-blown grit, a leaf, one touch could be junk. 2 touches in quick succession is probably legs. The flytrap isn't being clever about this. It has no idea it's hunting. It's running a rule that mostly catches food and mostly ignores debris, and mostly is all evolution ever asks for. A kitchen timer also counts, and you don't lie awake worrying about its inner life. Hold on to that thought, because it's going to come back and cause trouble. Step out of the bog, and the counting trick turns out to be the small stuff. Plants talk, not in any cozy sense, chemically, into the open air. When a leaf gets chewed, the plant leaks a cloud of volatile compounds, and plants downwind pick up that chemical smell and start bracing themselves, ramping up the bitter, toxic, hard-to-digest defenses that make a caterpillar's life miserable before anything has touched them. The classic demonstration came from Richard Carbon and colleagues working with sagebrush and wild tobacco. Clipped the sagebrush, and the tobacco growing nearby suffered noticeably less insect damage afterward. Something in the air had put it on alert. It's tempting to call that a warning, neighbor shouting to neighbor. Be a little careful there. The honest read is humbler and, weirdly, stranger. A plant releasing alarm chemicals probably isn't doing it to help the plant next door. That good deed is mostly an accident the neighbor is eavesdropping on, the way you might overhear a fire alarm meant for someone else's building and decide to leave anyway. It works best up close, over short distances. But the core fact holds. One plant changes its chemistry because another plant, some distance away, got bitten. No brain signed off on that. It just happens reliably in the gap between 2 living things. And then there's the big one, the story that launched 1,000 documentaries. Underground, plant roots tangle up with fung threads in a partnership called mycorrhiza. And back in the 1990s, the idea took hold that these fungal threads wire whole forests together into one connected system. Nature's editors gave it the name that made it immortal, the Wood Wide Web. Suzanne Simard at the University of British Columbia became its great storyteller. Big old mother trees, pumping carbon and warnings and nutrients through the soil to feed their seedlings. A forest as one nurturing, communicating family. It's a gorgeous picture. You can feel why it spread. Here's where this kind of story has to do the hard thing and check itself. In 2023, a review led by Justine Karst at the University of Alberta went through the actual evidence and found the beautiful version is standing on far less than people assume. These underground networks have been rigorously mapped in only a couple of forest types, against tens of thousands of tree species. The amount of carbon supposedly shuttled between trees may be far too small to matter much. And the tender idea of mother trees deliberately feeding their own kin? Not well supported. The fungi, it turns out, may be moving resources around for their own benefit, running their own business, and the trees are more like customers than family. That's the bucket of cold water. But notice what it does and doesn't do. It doesn't say the network is fake, the threads are real, resources genuinely move. Simard stands by her work, and most researchers agree the connections exist. The fight is about scale and intent and how much romance got loaded onto a real thing. So the grown-up answer isn't debunked and it isn't proven. It's real, smaller than the legend, and not the warm family reunion we wanted it to be. If you came here for a tidy hero, sorry. Science just took its own most beloved story to the workshop, so strip all the romance off. No mother trees nursing their young, no deciding flytrap, no plants whispering to save each other. What's actually left on the table once you've thrown out the wishful thinking? Everything that matters, it turns out. A flytrap that counts touches and resets its own memory after 20 seconds. Plants that read chemicals out of the air and retool their bodies in response. Living things rearranging their own chemistry based on what's happening around them, sensing, signaling, a rough kind of short-term memory, and not one of them has a neuron to its name. The flytrap's counting is completely mindless, and it completely works. Those two things are true at the same time, and that's not the consolation prize. That's the actual discovery, which is the part I keep turning over, and I'm curious where you land. We keep walking up to plants and asking, are you smart? Like us? Do you think, do you choose, do you care? And the plant keeps quietly failing the exam, and we keep feeling let down. But maybe the failure is in the question. We built the entire test around one model of a mind, ours. Central control, a self in charge, somebody home making decisions. That's one solution to the problem of staying alive. It is not the only one, and there's no law of the universe that says it's the best one. If something can sense, react, warn, and remember with nobody steering, does that count as intelligence to you, or do you need a mind behind it before the word applies? I genuinely don't know the right answer, and I'd take yours in the comments. If you like questions that quietly refuse to close, stick around. Subscribing means more of them. Because here's the thing, the still garden was trying to tell you the whole time. We assumed intelligence needs someone to be doing it. A plant is what it looks like when there's no one there, and it works anyway. Whatever that is, it was growing all around you while you called it scenery.